North Haven Middle School, grade 8 algebra students. It is time for dividing and simplifying radicals, part 2, which we're going to focus on rationalizing the denominator. So this is a video that goes along with the 11.5 worksheet or PDF or attachment or whatever you want to call it. That homework, that assignment was broken up into 2 parts. That's why there's 2 videos. And the second part of the assignment, the second part of the video, it does focus on rationalizing the denominator. So we're just going to jump right into it and talk about exactly what that means. All right, so here is a simplifying radical problem. But like the ones in part 1, you're probably thinking, well, I can't simplify anything here. I can't break it up. There's nothing I can do. You're done. Okay, technically that's correct, but what rationalizing the denominator means is that they do not want any radicals in the denominator, in the bottom of a fraction. So you can't leave a problem like this because you have a radical down there. So now I want to rewrite this fraction. That's all I'm doing is just rewriting this fraction so there's not a radical down there. So I'm going to write something that's equivalent to this without a radical, without a square root in the bottom. So, quick review of fractions. If I was doing 1/2 plus 2/3, all right, well, obviously I couldn't do that. I would need to get a common denominator to get my answer, but I would want to keep this equivalent to 1/2. I would want to keep this equivalent to 2/3, but alter the fraction somehow so that I can do the addition. So hopefully you remember that the common denominator here would be 6. So you'd multiply the bottom by 3 to get 6. You multiply this bottom by 2 to get 6. But now you multiply the bottom by 3, you'd also multiply the top by 3 because 1/2 and 3/6 are equivalent. Here, you multiply the top and bottom by 2, 2/3 and 4/6. They are equivalent. And then that's how I get my answer of 7/6. So now, back to this problem. I want to keep this fraction equivalent to what it is. I need to multiply it by something that's going to help me get rid of the radical down here, but not change the value of the fraction. So, how are we going to do that? Well, first, let's focus on getting rid of this radical here. I multiplied by whatever I needed to get a 6 in the denominator. That was my goal. I wanted that common denominator of 6. My goal here is to not have a radical, to not have a square root in my denominator. So what can I multiply the square root of 3 by to make it no longer be a radical? Well, if I multiply the square root of 3 by the square root of 3, I've talked about that earlier in the video. I'm sure your other teachers have talked about that when we're in class. The square root times itself, this is really the square root of 3 squared. Square root and square, those are inverse operations. They're going to cancel each other out, and I'll be left with just 3. And that's exactly what I want. If I have just 3 in my denominator, there's no longer a radical there. So if I'm going to multiply the bottom of this fraction by the square root of 3, well, then I have to multiply the top of the fraction by the square root of 3. Also, I'm multiplying it by 1, because the square root of 3 over the square root of 3 is 1. If I multiply anything by 1, it keeps its value. So that means this and whatever I get over here, they're going to be equivalent to each other, which is really, really important. And the square root of 2 times the square root of 3, that's just going to be the square root of 6. Now, if you're thinking, oh, I could keep going, I could simplify that 6 over 3, that you can't do. That is your final answer right here, because the 6 is under a radical, the 3 is not. There's no more I can do with this problem. That's going to be my final answer. All right, but more importantly than anything else, that is how you rationalize the denominator. You're going to multiply that radical in the denominator by itself to cancel out the radical, but whatever I do to the bottom of a fraction, I have to do to the top of the fraction to keep it equivalent throughout. All right? So pause that, rewatch it if you need to. If you need other extra help, come to extra help sessions being offered by Lion, Lucier, Benvenuto, and Khan, or email me or your teacher or Ms. Khan or anybody with questions about it. We'll make sure we get back to you. We can even hold some mini sessions. All right, I do think that rationalizing the denominator is the trickiest part of this mini radical unit that we're in the middle of. So rewatch this video. Ms. Khan made a great video about rationalizing the denominator. I would watch both of them. Like I said, I think this is the hardest, trickiest part of the radical unit. All right, so here's another problem. 6 over the radical of 2. I need to rationalize the denominator. So like we just talked about, if I multiply the radical by itself in the denominator, that's going to be great because the radicals will cancel out. I'm left with 2. But whatever I do to the bottom, I got to do to the top. So I get 6 times the radical of 2. That's just going to be 6 rad 2. And if you're thinking you're done, you're actually not. This problem's a little bit trickier because now I can simplify the fraction I have. The radical 2 over the regular 2, that I can't simplify because this 2 is in a radical, this 2 is not. But here I have a 6 and a 2, both outside radicals. 6 over 2, that simplifies to 3. So my final answer here is going to be 3 radical 2. All right, so a little extra step, a little tricky in that one. All right, let's jump into variables, see what these look like with x's and y's and a's and b's and c's and whatever other letter you fancy. Square root of 5 over the square root of x. Nothing changes. If I want to get rid of a radical in my denominator, I'm going to multiply that radical by itself. And then whatever I do to the bottom of the fraction, I have to do to the top. Here, the square root of x times the square root of x is just x. Here, 5 times x, both in the radical. Rad 5 times rad x is rad 5x. There's nothing I can do. There's nothing I can simplify. This is in a radical. This is no longer in a radical since we rationalize the denominator. There's no more I can do with that problem. That's going to be my final answer. And make sure your radical bar extends over everything you want underneath that. All right. This last problem I'm going to do is kind of a props to the tops question. This is a very challenging question. It's going to take a long time, but there's a trick in it. See if you can pick up the trick. See if you can find the thing that's going to make this a lot easier. Don't want to spoil it. I might have already said too much. But anyway, here we go. So this is going to be the last problem I do in this video, the trickiest problem. It's going to be a giant problem. We'll make our radical in the denominator the square root of 6. And up here we'll go with rad 81 z to the third. All right, so this is a tough problem. I got some bigger numbers. I got a variable, and I got a radical in the denominator. And I need to get rid of that. So let's rationalize our denominator. And so I'm going to multiply that by the square root of 6 over the square root of 6. So that's going to cancel out, and I'm going to be left with just the 6 on the bottom. But on the top, I think 81 times 6, that's going to be 200 and... No, that's going to be actually... I lied. 486 z to the third, all under a radical now. So that's going to be my answer, but I hope you realize that I can simplify 486 z to the third. Geez, let's see. So this is why this problem is the last problem. It's going to take some time. I could do, I think this 9 times 54, because I've done this problem already out in my notes. That equals 486, so I'll break that down to that. And I'll break z to the third down to z squared and z. But actually, now that I look at it, the square root of 54 can actually be broken down into the square root of 9 and the square root of 6. So looking at this, I got the square root of 9 times the square root of 9. This is all over 6, by the way. Square root of 9 times the square root of 9 times the square root of 6. So let's see, that's going to be 9 rad 6. And square root of z squared and square root of z. So square root of z squared, that's just z. So I get 9z rad 6z. I'm going to get all of that over 6. And man, that's a lot of work, breaking all that down. And breaking down that radical is a lot of work. But hopefully, you're realizing the shortcut that we could have done. The reason I like this problem so much, and the reason I put this problem in this video, is because the whole point of this video has been rationalizing the denominator. So that might have been your first thought. I made sure it was the first thing that we went to, but there's actually an easier way of doing this problem. You don't have to rationalize the denominator right away. It never has to be the first thing you do. So when I look at this problem, the best way to go about it would actually be to look here first. See if you can simplify what you have here in the numerator. Leave the denominator alone for now. We'll have to rationalize it eventually, but it might make our life a lot easier if we do that later on. So here, I could rewrite that as the square root of 81 times the square root of z squared times the square root of z over rad 6. So now that's just going to be 9z rad z over rad 6. And then, well, now I rationalize my denominator. So now that I've simplified the top, now I multiply that by rad 6 over rad 6. And look how much easier this is going to become. I'm going to get that 6 on the bottom. I'm going to get 9z and then the rad 6z. I get the same answer we had here. I don't have to break down 486z cubed. I break down 81z cubed in the beginning, and my life's a lot easier. Hopefully you realize that neither one of these answers is your final answer, because the 9 and the 6 can be simplified to 3 over 2. So my final answer to this problem, if I could squeeze it in this corner, is 3z rad 6z over 2. Oh man, if you can read all that, a lot of work for this problem, but a lot of unnecessary work. So again, final answer was 3z radical 6z over 2 is the final answer. As I zoom in so you can really get a good look at it. But the whole point there is you guys are thinking rationalizing the denominator the whole time. That does not need to be your first step. You can save a lot of time if you simplify as much as you can first. Going down. Simplify as much as you can first, and then rationalize your denominator. All right, that does it for this video. Keeping it short again, look at Ms. Khan's video on rationalizing the denominator. It's also really helpful. Tune in for our office hours and email us with any questions. Good to get back into a regular routine kind of while still being at home doing work that I think is more of your caliber, more challenging. Hopefully you guys are rising to the challenge. Stay safe, stay home, and wash your hands.